Okay, 2.2 is power functions and modeling. Any function that can be written in the form of y equals k times x to the a, where k and a are non-zero constants, is a power function. The constant a is the power, and k is the constant of variation. So we talked about some of these back in, I think it was 1.9, okay? I'm sorry, I didn't finish that. So it is a constant of variation or the constant of proportion. We say f of x varies as the eighth power of x, or f of x is proportional to the eighth power of x. So you're going to be looking for the words proportional or varies, okay? That's what's going to tell you that it's a power function. All right, so let's look at some common formulas from geometry and science. So we have circumference, which remember is c equals 2 pi r. Well, r is our variable, and we're looking for what the power is. Well, that's r to the first, so the power is 1. And the constant of variation is the 2 pi. It's the numbers that are with the variable. All right, then we have area of a circle, a equals pi r squared. Your power is 2 from the r squared, and your constant of variation is just pi. Then we get the force of gravity. It's F equals K divided by D squared. Remember, it's K times X to the A, so we need to bring this up. And the only way you can bring it up is if you change the sign of the exponent. So this is the same thing as F equals K times D to the negative 2. So we can see our power is negative 2, and K is our constant of variation in front of it. And then we got Boyle's law. V equals K divided by P. Same idea, we're going to bring that up. So it's become V equals K times P to the negative 1. So our power is negative 1, and our constant of variation is still our K. All right, so writing and analyzing power functions. And it says in the formula D equals 1/2 gt squared, state the power and the constant of variation. Well, we can see our power is the exponent, the 2. And so that means t is our variable. So our constant of variation is going to be the 1/2 g. Example 2 says write a statement as a power function using k as the constant of variation. It says the area A of an equilateral triangle varies directly as the square of the length s of its sides. So we see the word varies. So we know our first part is going to be what's in front of it. Well, what varies? The area A of an equilateral triangle. So A varies means equals K. Remember, directly means to multiply as the square of the length S. So that would just be S squared. So we get A equals KS squared. In example 3, let me move it down to it here. It says state the power and the constant of variation for the function. Graph it and analyze it. All right, well, before we can really move too far, notice we have that 4th root of x. And we had that rule a while back that said if you're taking if you have some root here, whether it's a square root, cube root, 4th root, 10th root, of a base raised to some exponent, let me go ahead and write out the word root, you can rewrite that as the base raised to the exponent over the root. So in this case, that f of x equals 2 on the 4th root of x is the same thing as saying 2 times x to the exponent's a 1 over, and the root is the 4th. So it'd be 2 times x to the 1/4. All right, so now we know our power is 1/4, and our constant of variation is going to be the 2. All right, so we're going to graph this and look at it. We're going to see it looks something like this. All right, and then it said to analyze it. So let's just go through some of the stuff we talked about way back in chapter 1. So we can look at it and we see that the domain is from 0 to infinity. The range is also 0 to infinity. We can see that it's going up, so it's increasing. It has no symmetry. Nothing splits it in half, can't lie on top of itself. It doesn't have a local or relative minimum, but it does have an absolute minimum. And that's the very bottom point. And so the absolute minimum, sorry, that doesn't look right either. I'm just going to abbreviate it, is that x equals 0. It does not keep going down, so we can say it's bounded below. All right, just a few things there. Okay, so moving on. So we're going to talk about monomial functions and their graphs. It says any function that can be written as f of x equals k, or f of x equals k times x to the n, where k is a constant and n is a positive integer, is a monomial function. So just know that a monomial function, we know what a binomial is, x plus 2. We know what a trinomial is, x squared plus x plus 2. Monomial is just a single term. It's what's in between the plus or minus signs. So like x squared, or 2, or x, or 5x. Monomial function. Sorry, I got distracted giving you examples. So for any power function, f of x equals k times x to the a, one of the following things will happen if our x is less than 0. The first thing is going to be our function is undefined. And so that will be if we have something like y equals x, or negative x to the 1.5. Our function is an even function. So our function is an even function. So that's that y equals x to the 0.4, or the function is an odd function. An example, that would be y equals 2x to the negative 3. And so we can see on this first one that our a is greater than 1. Second one, our a is between 0 and 1. And the, negative 3. And on the last one there, our a is less than 1. Or less than 0, excuse me. Because it's negative. Alright, so we can look at the graph below here. It says the graphs below represent the 4 shapes that are possible for general power functions. So, of the form f of x equals k times x to the a for when x is greater than 0. And so if we look at the one that's there in, what color is that, blue, that's that y equals x to the 0.4. That's what it would look like. The one that's in green there, that's decreasing, is our y equals 2x to the negative 3. Now the other one, the one we said that would be undefined for x is less than 0, actually I didn't write x is less than 0, but it is, would be that y equals negative x to the 1.5. And that will be in the second graph right here. So y equals negative x to the 1.5. So if we're trying to find the power function, and I give you a table, okay, and you put it in and it tells you there's an error, what's happening is that's going to have a negative, x is going to be less than 0. So what you're going to have to do on that is you're going to have to do the positive, which would be this one right here, and then you're going to make your x become a negative number, okay? So whatever you find for that a value will become negative. All right, so graphing power functions. Example 4 says describe how to obtain the graph of f of x equals negative 2x to the 6 from the graph of g of x equals x to the 6. State whether the function is even or odd, sketch the graph by hand, and support your answer with a grapher. So first thing, it wants to know the transformation. Well, we did transformations back in the middle of chapter 1. So let's just go through it. We have f of x equals negative 2x to the 6. What is the negative going to do? It's going to reflect across the x-axis. And what does the 2 do to it? It's going to be a vertical stretch by 2. Now, is this function even or odd? Well, we can find out. We can plug in f of negative x and see if we get the same exact equation. If we do, it's even. Since it's only a monomial, if the sign changes, it's odd. And, well, it's going to have to be one or the other because it's only a monomial. All right, so when we do this, our negative x to the 6th becomes positive x to the 6th, and negative 2 times positive x to the 6th is negative 2x to the 6th. So when we compare this back to the original, we can see that it is the same. Therefore, that means it is even. All right, and then we can graph this. We could pick some ordered pairs here. So let's see. Let's try like negative 2, negative 1, 0, 1, and 2. So when I plug in negative 2 to the 6th, that's what? 64 times negative 2 would be negative 128. Obviously, we can't graph that. Plug in negative 1 to the 6th, and that's 1 times negative 2 is negative 2. 0 to the 6th is 0 times negative 2 is still 0. 1 to the 6th is 1 times 2 is negative 2. And 2 to the 6th is 64 times negative 2 is negative 128. All right, so we're only going to be able to graph these 3 in the middle. Okay, so we got 1, negative 2. Or excuse me, negative 1, negative 2, 0, 0, and 1, negative 2. And so what it is because it's x to the 6th, it's going to have kind of a quadratic look going to it, but it's just going to be a little wider here in the base part before it curves. Let me try that a little bit better. So it's going to be a little wider right there at that base of it before it curves, and then it's going to go down really quickly, because just think, one more over and we got to be down at negative 128. So it's going to go down quick. All right, and then you can plug it in your calculator and you can check that out. Example 5, we're going to match the equation with one of the curves labeled in the figure. So, let's look at some of them. Well, let's see here. We got f of x equals 3 on the 4th root of x. So, that 4th root of x is going to be like a square root of x. So, if we look at our answer choices, we can see it's probably going to be A or B, because D is in the 4th quadrant. It's a reflection of something that's in the 1st quadrant. And then this here is going to be a rational function, which means it's going to have x on the bottom. All right, well, if I'm unsure which one, let's plug in a number. So let's plug in 1 for x. So I'm going to do this over here on the left. So if x equals 1, we get 3 on the 4th root of 1. Well, the 4th root of 1 is 1, so we get 3 times 1, which is 3. So that would be our y value. So we're going to have the ordered pair 1, 3 on our graph. And so let's go check. If I check the first one, 1, 3, there it is. Check the second one, 1, 3, uh-oh, that can't be it then, right? So if you wanted to check the others, well, they're all in the bottom quadrant, so it couldn't be it anyways. So A goes with number 1. All right, look at 2. 2 says f of x equals negative x to the negative 2. Well, if I don't like that exponent, I can send it to the bottom. Now we'll have a fraction, so I have negative 2 over x squared. Well, if it has x on the bottom, that's that rational function. It's going to have that asymptote that we talked about before. And so the only one here that has an asymptote is going to be answer choice C. And we can see that the asymptote would come down like this, in between. All right, so C goes with number 2. And if I want to write that equation, that's what f of x equals 2x to the negative 2. All right, check out 3 or 4. Well, let's go to 4 because 4 I see that negative. So that negative tells me it's a reflection across the y-axis, so it's going to have to be D. Whoops. And so we get f of x equals negative x to the 4/3. And so by default, 3 would have to be B. Now let's talk about y. Notice it's the cube root of x squared. So it's got a radical there, so it's going to look like a root. Also, if I pick a point and plug it in, let's say x equals 1. So I'm going to do that over here on the right. If I let x equal 1, then I get 1.2 times the cube root of 1 squared. So 1.2 times the cube root, 1 squared is 1. Then the cube root of 1 is 1. And so I end up with 1.2 to be the y value. So I'm looking for it to have the ordered pair 1, 1.2. And so if we look at this, we go to 1, and that's a little bit above the 1. So therefore, it is our answer. And so we know that B is f of x equals 1.2 on the cube root of x squared. All right, so moving on along. Then we have Charles's gas law. So this is going to help us with the word problems. Guys, we did this before in 1.9. The rules are always the same when you're dealing with variation, okay, with these word problems. You're going to look for the word varies or proportional. So first I'm going to read through it, and then we'll do that. So it says the volume of an enclosed gas at a constant pressure varies directly as the absolute temperature. At the pressure of a 3.46 liter sample of neon gas at 302 kelvins is 0.926 atmosphere. What would the volume be at a temperature of 338 kelvins if the pressure does not change? Okay, it's always going to be the same thing. The first sentence is going to help you set up an equation with all the variables. Second sentence is going to give you everything except the k, the constant of variation, so that you have to solve for k. Once you solve for k, then you'll have a general equation for these. Then it's going to tell you what you need to find in the last part of it. All right, so let's look at it. Look for the word varies or proportional. Right there. Now this one's a little tricky because it has kind of two things over here, but it's always going to be just one thing on your left side of the equal sign. What varies? The volume of an enclosed gas at a constant pressure. So the volume is what's going to vary. So volume varies is equals K. Directly means times. Remember, inversely means divide. Jointly would be multiplying several variables. So varies directly as the absolute temperature. Now, we also, though, have this pressure. Okay, and it's a constant pressure, so they don't mention it in the other part, but because it is constant, we're also going to multiply by it. Then it tells us if the, all right, so this is the first sentence. We've set it up. We've got all of our variables. Then the next sentence is going to give me everything but K. So it says if the pressure of a 3.46 liter sample, that's the volume. We know we're going to give us everything but K, so I'm going to put my equals K, of neon gas at 302 kelvins. That's a temperature, so times 302. And it says the pressure of this is 0.926 atmosphere. All right, so we get 3.46 equals K times, let's multiply those together. I don't have my answer here, so I'm going to have to do it as well. So 302 times 0.926 is 279.652. And then we're solving for K, we're going to need to divide by that number. And so we end up with K equals, so we're going to take 3.46 divided by that number that we had. And I got 0.0124. Now, we're going to take this K and we're going to plug it back into this equation. So we got the volume is equal to 0.0124 times the temperature times the pressure. Now that we know that, we can go ahead and solve the problem. So it says what would be the volume, so we're after V, what would the volume be at a temperature of 338 kelvins if the pressure does not change? All right, so we know we're after V. We got our 0.0124. The temperature's at 338. And it says that the pressure doesn't change, so our pressure is still going to be 0.926. All right, so we put that in our calculator. And I got 3.881. Now, I only use the 0.0124. If you use the value that was already in your calculator, yours will be just a little different, but it should be close. All right, so it's a word problem, so we need a label. So volume is in liters. And so there's our solution.